So we'll move to the next speaker, with Professor Eric Fosler-Lussier. So he is a professor of computer science and engineering with a quarterly appointment in the linguistic, and he graduated with his PhD from Berkeley, and then after that he has been member of technical staffs at Bell Labs, Lucent Technology, and visiting researcher at Columbia. In 2006, Professor Fosler-Lussier was awarded the NSF Career Award, and then in 2010 he was presented with the Lumley Research Award by the Ohio State College of Engineering. He's a recipient of several Best Paper Awards as well as a Department Teaching Award. So today, I think he will be talking, understanding how to understand the teammates. So this is more focusing on the human-machine teaming aspect. So without any loss of time, Eric, welcome to this virtual session. If
Thank you.
can share your slides and get started.
Okay, we'll do. All right. So I'll start by saying two things. One is, you know, I am not a pathologist, as you can probably guess. I do a lot of things in speech and language processing. That's my background. But we've been thinking a lot about like, what does the next generation of interactive systems look like? I've worked quite a bit with medical and biomedical data over the years, as you know, in partnership with a number of people, including Raghu. We're just about to send off a paper on wet lab protocols. So, but the thing that I wanted to speak to Anil's question about, you know, are we replacing pathologists? I think the answer is no, we shouldn't be. I mean, I think Raghu kind of spoke to that too, but I'm hoping that you guys might have an answer in part via this talk. And this is really more about ruminations that we're, instead of actual work. And then I'll talk a little bit about some things that you see when you start integrating language into thinking about these processes. But I think the way that we want to think about this is how do we provide good teaming in terms of decision support? Because I will tell you the number one reason why AI will not replace pathologists anytime soon has to do with legal liability. Nobody wants to sign off on a mistake, right, at this point, using it either from the pathologist side or from the tech side of like, oh, you misdiagnosed this, right? So it's very clear that we need multiple kinds of expertise when we're thinking about these processes. So, so let's start. Oops, hang on, change window. Okay. So here's my agenda for today. I talk a little bit about you know, human-machine teaming and thinking about complicated workflows, and what we're really talking about is that idea of partnership, that no one part of a team, when you think about a team, right, no one part of the team is you know, indispensable without the other, right? That would be a perfect scenario, right? So the big picture question is, how can we have automated agents that facilitate that kind of decision making? And I'm going to try and spin a little bit of a story of where we're thinking about, like, where does the next decade look like? And so we'll talk a little bit about, like, where are we now? And then we'll talk about, like, what does that mean, right? You know, one of the things that I'm not going to touch on too much, but I want you guys to think about as we kind of go into discussion about this is what can work with pathology workflows. I personally am not a pathologist. I don't know much about pathology workflows. I've worked with other workflows in medical domains. You know, and the question that we should be thinking about as a community is what should be, you know, working with pathology workflows. So I'll start by talking a little bit how we partner with machines in conversation now, and then that will lead to some things about how, how we should talk about it in the future. And what are those challenges? What are the big challenges we have to think about from the tech side, particularly on the human-computer interface, right? One of those that is my particular research area that I'll touch a little bit more on is how do we learn with sparse data examples. I have a nice sort of medical domain example of this having to do with medical language. So, all right. So let's think a little bit about, the interactive capabilities. How do we interact with our devices now, right? It's no longer that we're just looking at a computer screen, right, and reading and typing, right? But now we have things like we have personal assistants, right? That on your phone that you can say name of thing here, so I don't set off everybody's phones, right? What's the weather going to be today, right? That kind of thing. We're used to that kind of interaction, right? And that kind of stuff. And we now have these assistants that kind of sit in our homes and can react to spoken commands, right? We have the, a lot of ability to annotate things now, right? In terms of pencils and all sorts of fun things where you can kind of scribble on things and it's not just input. And we've always had mouses and stuff like that, but the modalities are becoming much more natural, right? And the bottom right is really indicating things like eye tracking, right? So we're starting to see things where a lot of the phones that you see now can track things like where is your head pointing and where, even to the point of like, where are your eyes gazing in a rudimentary way. With specialized hardware, you can do pretty well, right? So there's this interesting, question of like, okay, these things are coming down in cost, right, in terms of the technology, which means they're going to be more prolific, and then so you can expect them to be in these sort of workflows, right, and the abilities are going up. So this is a lovely time, and a lot of the ways that people are thinking about each one of those modalities is really thinking about one at a time, right? So wouldn't it be exciting if you could circle something and talk about it at the same time? Or you could look at something and talk about it at the same time, or all three, right? And other modalities might crop in there as well, right? So these are the kinds of things we're thinking about. So as I said, I think a lot about this, about the language aspect of it. I am not so expert in eye gaze. I don't know much about gesture. I mean, I know some things, but we're starting to get to the point where the next generation of interaction needs to think about how these modalities work together. And that is a grand challenge. We don't have good ways of thinking about that, okay? So I want you to think for a minute about your last conversation with your favorite virtual agent, right? Whether it be whether it be the one from Apple or the one from Google or the one from or Amazon or whatever, right? Take your pick, right? So who controlled that conversation, right? It's user directed, right? It's the user. The user is directing the end, right? And the virtual assistant is really responding, right? So there's this sort of back and forth, right? How complex was that conversation? At this point in time, most of our commands are single interactions. It's very rare when you start to get multiple pieces of information that you need to gather to get one of these things. There are other systems that do that, right? But if you just think about like our virtual assistants, right? There's very little follow through. This is an active area of research, right? This is something that all of these companies are starting to work on, right? And the other question is, how could you tell if the machine understood you, right? How does it build trust in you, right? In the sense of, well, it did the right thing, right? Okay. Or it came back, if it does, but sometimes it doesn't come back and do the right thing, and that decreases trust, right? So there is this idea of like getting results out of the system that are useful to you really builds trust, okay? And so that's something that we need to think about when we're thinking about working in pathology workflows, for example, okay? I want to give another example, which is a little closer to my own research. This is a little video. Oh, dang it. Hang on a second. I think I forgot to share. Let me reshare. I'm sorry to stop and restart, but I need to share with audio. Pardon me. Okay. Yes. So I want to share an audio clip, and somebody put in the chat if it doesn't work. But this is a little video clip. I'm sorry. Of this is an avatar that we built with the OSU Medical Center. This is a collaboration between ACAD, which is a design group on campus, and Department of Linguistics and Computer Science and the medical school. It's mostly being run by the medical school, where we get medical students to practice taking medical histories. And the question is, why? Why do you do this? Well, basically, and those of you who are pathologists will have known this because you've gone through medical school, right? So you had to learn to take a medical history from a standardized patient, probably somewhere along the line, right? And those were human actors. Human actors are expensive. So there's really not a lot of a chance to get better at this. So the idea is if we can have an avatar, then you can actually make something much more cost effective. So here is the demo. Whoops, hang on, sorry. I accidentally did that.
Hello, doctor.
Hello, Mr. Rodriguez. How are you today?
I hope you can hear that.
Generally pretty good, except for this back pain.
Where does it hurt?
It is mostly in my lower back.
How long has it been hurting?
Almost a week, I think.
Have you been taking anything for the pain?
I have been taking ibuprofen for a few days, but that is not helping much.
Okay, at this point, I didn't go through an entire scenario, but the idea is that the student gets feedback based on in a little web page, you know, of like what questions did they ask and what didn't they ask, because there's supposed to be certain things that you hit along the way to ask. So some interesting things that crop up from that is like, how do we build trust in this? Well, it turns out, okay, when the first versions of this system, and I'll talk a little bit about this later. Yes, good. The first versions of this were typed, right? So you had to deal with typos, but apart from dealing with typos, you know, you knew what was coming out was good. When we started putting on a speech interface, all of a sudden we were getting speech recognition errors. If you've ever worked with, you know, a dictation system, you know that there are errors that crop up. And they're usually the more difficult words, right? So that was one of the things. So we found actually, when we started putting the transcript in this little box up here, right, then that people started focusing on the things that it got wrong, and we lost trust, right? That was a problem for doing that. But if we took away those dots, right, then all of a sudden it's like they didn't know if it was listening or not. And sometimes it wasn't listening, right, because the system was broken. So we put in these little dots that kind of represent the words and saying, oh yeah, I'm listening to you. Okay, and then it responds correctly, right? So so this is an interesting thing about thinking about interfaces for working with people is like, what is it that you reveal and what is it that you don't reveal, right? That's an interesting problem. Okay. So.
Hello, doctor.
Yes, we're done.
Hello, Mr. Rodriguez.
We're done with you, Mr. Rodriguez. Thank you. Okay, so the question is, you know, who controlled that conversation? Again, it's very patient-driven, or sorry, doctor-driven, right, or student-driven, right, conversation. The conversations are a little bit more complex. There's a little bit of history. I will tell you that there's not a lot of history that's being remembered between questions and underlyingly. It has the appearance that it might be, right? So how can you tell if the machine understood you? It responded correctly, right? So again, there's this sort of metric on this. And in fact, we go and measure these things like, did it actually produce the right answer? Now, this system was actually kind of built, I was gonna say, the other thing is that it's very important in this system that a specific answer is given. So here we actually require a lot of medical expertise to give the answer. Okay. So this is actually a very important thing of like the expertise that's needed to build one of these things. Okay. So I want to give you a little thought experiment. Like, what would it be like if we started to capture things like input from pathology team conversations, right? And I know that often pathologists are working by themselves, but one of the things that we've been thinking about is like, in thinking about how pathology, like if you teach somebody to do pathology, right, in a teacher-student relationship, right, there are conversations that happen about these. Can we actually mine these kinds of conversations, right? So here's a conversation that's going on, oh, in fact, maybe there's actually somebody who is not present in the room, right? So the modalities might change, right? So you guys are now looking at something over the internet together, or maybe there's some collaborative thing going on, right? So we have to think about space. We have to think about like how all of these things sort of interact, right? Okay, and now maybe we're gonna throw our own little virtual assistant in there that can help, okay? And this is the interesting thing, like how does that change the dynamic, right? And it really is about how does that virtual agent now become part of that conversation and not replacing somebody in the, well, not replacing anybody, but augmenting it, right? So for example, we might be want to capture like annotations that are going on. Oh, this is an interesting region. And trust me, I don't know if that was an interesting region. I just put down like a marker on that thing, right? So I don't look for anything deep in there. All right, but the idea is that annotations, right? And knowing where people are gazing, right? And what are they looking at? And what are they talking about, right? There's this interesting question about registration, right? If I'm talking about something and circling it at the same time, that's something that's a technical challenge that we don't know how to solve yet, right? But it's something that is an interesting idea of like, how does gesture and circling this area. And the other thing is that the circling the area, right? There's sort of this uncertainty. It's like somewhere in here, there's something interesting, right? So there's sort of this sort of distant, what we would call in the ML world, distant supervision idea of like somewhere in there, there's something interesting, but I'm not, and it's obvious to the human, but it's not necessarily obvious to the computer. So how do we build those kinds of interfaces? Okay, how do we bring in other types of medical records that to help augment like this, right? So this slide, comes with it a whole medical record that goes with that, right? And are there pieces of that we need to be able to pull up? Are there records that we might want to search? It's like, oh, this looks like a case that I saw back last November. Can you pull up that case, right? That would be something that a virtual assistant could definitely help with, right? But an interesting question also is, when should the virtual assistant chime in? When could it provide you with additional information that is in a way that doesn't interrupt the flow of your work process, but augments it, right? This is the exciting question. Like, how do we build a teammate? A teammate, like a human teammate, would feel like they could interject at a point. We don't know how to do that conversation. I mean, we're just starting to understand that idea, right? From this. So this is a really kind of interesting time to be thinking about these types of issues. All right. I am running completely like towards the end of my time. So I'm just gonna put up a couple of challenges here that I'm thinking about. It's like, what are the challenges? First of all, how do we build trust, right? I kind of give you this idea of like, in our virtual patient system, we built trust by, not actually revealing everything, right? Because it turned out when we revealed everything, like people started to trust us less, right? And so some of it is a little bit of, understanding when to, when to reveal things and when not to reveal things, right? But it also creates scenarios like, if the machine learning algorithm, for example, is uncertain about what the output should be, how do you communicate that uncertainty? This is a problem. More to my heart, are things like mixed initiative systems, like when should computational partners be listening and when should they be suggesting? Right? This is a really tricky question. How do we integrate information from these multiple modalities, right? We have this idea of deixis, right? If I say, look at that, right? And I'm pointing at something and I'm looking at it, right? Your eye gaze goes to something and there's something that's of interest, but we don't know exactly what that is, right? But we need to know there's a time registration that has to go between that, right? The coordination, and just looking at all these things in terms of, Rego mentioned the idea of attention mechanisms, right? And how do we draw attention to these things? So in machine learning, we have this idea of attention, and in user interfaces, we have an idea of attention, and basically knowing how to meld those is a grand research challenge, right? So from the technical side, we have like things like explainable AI systems, how to generate those explanations, and in fact, generate them with language, right? Like being able to explain, not just in like, oh, look, here's a picture, but like, here's a picture and why am why did I reach that decision, right? Making systems more robust to that kind of uncertainty and error, right? How do you build these systems with little data, right? And if I don't have enough time to talk about it, but that's one of the things that we look at is like, how do we deal with sparse, long-tailed language distributions and building these types of systems? So, all right, given the time, I think I will stop right there and open for questions.
Eric, thanks a lot for your wonderful talk and showing the wonderful tool. So let's open the floor. I think there was a comment saying this is a wonderful tool. Hitesh, do you have any follow-up questions for Eric?
I do. This is Mike.
Yes. Okay, please proceed.
As part of one of the efforts that we have at the University of Pittsburgh and with our health system partner, this concept of a digital assistant for doctors is a very strong one. Mm-hmm. We're actually piloting a program in the critical care unit where we use speech to text to record notes as care teams round on patients in the ICU. I think it'd be useful to introduce you to that team. One of our trainees, Andy King, who is a postdoc in our department, is leading that effort, but essentially to create tools that help to document discussions among professionals, obviously a strong intersection space. I think it's also critical to have such tools in pathology, the so-called, I see a funny area on the slide, it's not like the rest of the slide's X, but this is something else. Can you help me figure out what that is a very powerful concept for AI applications to the practicing pathologist. So there might be some intersecting areas of collaboration where I might introduce you to our team in Pittsburgh, and you then could get introduced to this team that is funded by our healthcare system to essentially create digital assistants in a different care setting, and it might lead to some convergence in the middle.
Yeah, that's great. And in fact, there is a workshop coming up on medical conversations, which might be run by them. I'm not sure. I think it was somebody out of Pittsburgh who's running it, but I'm not 100% sure. So yes, and one of my former students just went off to Pittsburgh actually as a postdoc in the BMI department as well. So there's some, and I know some of the CMU Pittsburgh language folks. So.
Who's the person that's going to the postdoc at Pittsburgh?
Oh, that's Denny Newman Griffiths. So he's currently in BMI.
You know what? Your audio is breaking up a little bit. Could you type his name in the chat box?
Yes, we'll do.
All right. And if you could send a pointer to that workshop or meeting, that'd be great.
Yeah, I just saw the announcement in my email, so I will see if I can find it.
Thank you.
Thanks, Michael. So I think Eric Hitesh has a question saying, how do you ensure the system and tool gets validated?
I think that's an excellent question, and that is something that we're sort of figuring out, right? So in the case of the medical virtual patient, right? That is easier in the sense of, we have 150 medical students who are required to go through the system and use it every year. So we actually get some validation that way, and we kind of look at that. I think what's interesting and tricky about this type of, like, moving this type of large source thing into this more sort of, we'll call nuanced domain, right, is that data is much more expensive to collect, and it's much more time consuming, and validation and understanding that I think is going to require, a lot of interesting questions to be asked. One of the things that we can do is look at, to what degree do captured interactions help us to better focus on improving, like, machine learning algorithms to look for things that are already validated into, like, pathology reports, right? For example, so we can learn about linkages between image and text, right? One thing is that's there. So that is a resource that's there. I think we're still thinking about that.
Okay. Are there any additional questions for Eric? Otherwise, we can move to the next talk. Okay. So thanks again, Eric.